Hi, in this video we are going to see about how to create a line model through Ansys workbench and shear force and bending moment diagram results. Okay, let's select the static structural from the toolbox. Then now we have to select the materials. So for that we have to go through this engineering data, then select the material or create your new material. So for select the standard materials, we can go through this engineering data source. So under the engineering data source, we can see a lot of materials. So this first category is this is the category of materials. So either we have to use structural material or thermal materials. So we have to select from the category. So here are the general materials, and under this we can see the materials that we are commonly using. So aluminum alloy, concrete, copper alloys. So these are the kind of general materials. So if you want to see the properties of these materials, you have to select this. For example, a stainless steel. So if you select this stainless steel, means you can see the properties of the stainless steel under this row. So you can see that the densities, Young's modulus, shear modulus, pulse modulus, and various properties of this selected stainless steel. So for this project, I am going to use this stainless steel as a material. So we can use this plus symbol to add a material to the engineering data. So after that we can go through the project schematic window. So now we have to construct the model. So for that you have to go through this geometry. So right click there and go to this design modeler. So we are using design modeler interface to create the new geometry. So starting design modeler. So now the design modeler window has been opened. So now we have to construct the model. So assume I'm going to create a rectangular beam with a length of 100 mm, 1000 mm. Okay. So I'm selecting this XY plane. Now go to the sketching. So this is a beam model, right? So I'm going to use the line modeling option. So just we have to create a line for the length of the beam. So under this dimension we can set this general for the length of this line, and to locate this line I'm going to create another one dimension from the origin to the end of this line. So here the h1 and h2 are the notation for the respective dimensions. So the h1 indicates the length of this line and h2 indicates the distance from the origin to this left end of the line. So this beam is going to be 2 meter length, and from the origin, so it is in symmetrical portion, so it will be 1 meter. Okay, so now we can add the cross section for this line. So again, modeling. Now we are going to convert this sketch into a line model. So here you can see the concept, and under the concept, so there is a lines from the sketches, right? So select the lines from the sketches. Now we have to select this sketch 1, apply, then generate. So now the line modeling has been created. We have to add the cross section for this line model. So to add the cross section we have to go through this again concept, and the bottom and the end of this concept tools you can see the cross sections. Here are the various cross sections are available: a rectangular, circular tube, C channel, I channel. So for the simplification I'm going to use this rectangular cross section. So just choose this rectangle, and now we have to provide the dimension for this rectangular cross section. So I'm going to use the 10 mm cross 20 mm cross section. So here the breadth and height, so 10 mm. So here the units in meter, so you have to use the conversion. So 10 mm breadth and 20 mm with height. So now we have to assign this cross section into the respective line body. So under this spot you can see the line body. Now the cross section is not selected, so we can select the cross section through this. So rectangular one is the cross section we have created. Now the cross section has been assigned. Now again generate. To see the cross section along with the line body, we have to go through this view and display cross section is solids. Here it is. So turn on this to see the beam along with the cross section. So here the model has been generated. Now we can do the analysis of this. So we have completed the model. Now we can go through the project schematic window for the further operations. So file, close design modeler. Now the geometry has been constructed. Okay, so let's see the mesh, the load applications and deformations on the next video. So please watch the deck too. Thank you for watching.